Hello, grade 3 students. How are you? You did very well in the class today. And again, I'm welcoming you to this recording because I don't want you to miss a lot of the homework. Well, some of you didn't do or were not able to do. All right. So here it is. In your textbook, pages 108 to 111 or 111. It's sun in the east and in the west. Okay, but let's review. All right. Now, does the sun rise and set in the same directions every day? You know, in here, the sun rises in the east and it sets in the west. This is the noon part of it. Okay, so it's the same direction every day. Now let's try this activity. It's a review of what you did last time. Congratulations for those who did it very well. For those who are not able to complete, let me help you. All right. So number one, observe the sun at 10 a.m. Where is the sun from your sitting position in your classroom? On your right, left, back, or front? Now we did this morning, it's on your front. It's on my front. Okay, write that. On my front. Number two, observe the sun at 12 noon. Where is the sun from your sitting position in your classroom? All right. Then it's not on my head because the sun cannot be on my head, but it's above my head, right? Above my head. Okay. And then number three, observe the sun at 3 p.m. 3 p.m. Where is the sun from your sitting position in your classroom? Where? All right. You guessed it right. We did it this morning. It's behind me. It's behind you. All right. Okay. Because you're facing the classroom. The sun is going there. It's behind you. Because you're facing the east, in the classroom. So behind you is the west. All right. Now, number four, repeat steps 1, 2, 3 for the next 3 days. Are the positions of the sun the same for each of the different times during the 3 days? What do you think? Well, we did it in the class today. Yes, they are. They are in the same position at different times during the 3 days. Now let's go to number 5. Use your hand to point to the path the sun travels through the sky in a day. Is the path always the same? What do you think? Yeah, the answer is this one, because this is a verb starting the question with is. The answer is also is. Yes, it is. All right, write that. Yes, it is. And number 6, what is your conclusion for this activity? Now, I am teaching you to become a scientist. And so, if you can write your conclusion in English, just by yourself, not by your mom or your dad, then you can become a scientist. And so you can write, I therefore conclude that the sun rises and sets in the same directions every day. Congratulations for doing it. And number 7, what is your evidence for your conclusion? The evidence is the rising of the sun in the east and setting in the west, in the same directions every day. Well, congratulations for doing it. Now you're ready for today's lesson on pages 108 to 111. Okay, so you just answered page 107. Now turn your book to page 108. Now let's try. Why does the sun rise in the east and set in the west? All right, to try this position here, we are to make this frame. Okay, behind you is the torch. The torch represents the sun, and you represent the earth. All right, and so the torch is shining behind you. The sun is shining to the earth, as it seems. And so right now, I want you to watch this video. Okay, why does the sun rise in the east and set in the west? Okay.
When I'm at the beach, one of my favorite activities is to get up early and watch the sunrise.
Watch this carefully. All right. I want you to look at this and repeat this as often as you can. Watch right now.
Get up early and watch the sunrise. But why does the sun rise in the east and set in the west? Welcome to Moo Moo Math and Science. In this video, let's discover why. The Earth rotates in 24 hours around an imaginary axis in a counterclockwise direction. This rotation causes our daytime and nighttime. As the Earth rotates, notice how the east coast of Australia moves into the sunlight first. Then all of Australia is in sunlight, and then evening arrives, and notice that the last part of Australia to receive sunlight is the west coast. So in the morning, when you look at the sun rising, you are looking east. And in the evening, when you see the sun, you are looking towards the west. Actually, the sun rises in the east and sets in the west only 2 times a year in each hemisphere. In the northern hemisphere, on March 20th, which is the first day of spring, also called the vernal equinox, the sun rises due east. Moving forward, the sun then starts setting more northeast. The sun continues to set a little more northeast each day until around June 20th or June 21st, which is the first day of summer, also called the summer solstice. After the summer solstice, the sun starts setting less to the north until September 22nd, which is the autumn equinox, or the first day of autumn. On this day, the sun again sets due east and sets due west. After this day, it will rise a little further southeast until December 21st or 22nd, which is the first day of winter, also called the winter solstice. After this day, it sets a little less south until March 20th, which is the spring equinox. It takes 1 year to complete this cycle. In the southern hemisphere, the first day of spring is September 22nd. The summer solstice is between December 20th and 22nd. The autumn equinox is March 20th, and the winter solstice is June 21st. If you'd like to know more about the path of the sun, this playlist will help. And as always, thanks for watching, and Moo Moo Math uploads a new math and science video every day. Please subscribe and share.
Okay, I hope you got it. It's from Australia, all right? And I got this from this Pelangi textbook. I hope YouTube will approve this one. Okay, and it will not have a problem because we need it in our class. All right. Now let us understand it more. Okay. You see this axis? Okay. Now look, if you notice in the video, the earth rotates on its own axis. All right. This is the axis, rotates counterclockwise. The earth rotates in a counterclockwise direction. That is from the west to the east. Remember? The earth rotates counterclockwise from the west to the east. But the sun moves in the direction of clockwise from the east to the west. Remember that. And this is what again? Yes, it's the imaginary axis. Okay? Now look at it. This is the earth. If you view it from where? Is it from the south or from the north? The sunset is here, and this is the sunrise. The sunrise is this. As the earth rotates on its axis, the sun appears to move across the sky. All right, it just appears to move, but the sun is not moving. What is moving is the earth. The earth is rotating counterclockwise. All right, and so when a part of the earth is turning towards the sun, just like this one, the sun appears to rise in the east. When a part of the earth is turning away from the sun appears to set in the west. You understand? Yeah. Look at this drawing here. If you want to know more, the earth not only rotates on its own axis, but also revolves around the sun counterclockwise. The earth takes 1 year to complete one revolution around the sun. All right. So that's it for this lesson. And now you're ready to answer. Ready to answer the activity right here. Let's try answering this activity right now so that you can complete the homework for today when you arrive home in the evening after school. This is it. As you know, we are to prepare for this things needed construction paper, torch, and scissors. No need because we already have the picture in here. Okay, so we are to label east on the left side of the frame and label west on the right side of the frame. This is the frame. East on the left side and west on the right side. This one is if you're facing the south. If you face the south, then the east is in the left side and the west is on the right side. But if you're facing north, the left side is the west and the right side is the east. Remember that? All right. Don't get confused. Don't get confused. So close the curtains and switch off all the lights in the classroom. We did it in the classroom. Yeah. Oh, just imaginary. Number 4, you hold a frame in front of you and ask a friend to stand about 8 feet away from you and shine a torch. You can use a cell phone, all right? An old or new one. And shine a torch at your back. And the torch is, remember, it's the sun. And you are representing the earth. So in the simulation, the torch represents the sun and you represent the earth. And then observe the sun through the frame. At this position, okay? Do you see the sun? You don't see because you're seeing the frame. The sun is behind you. So is this part of the earth experiencing daytime or nighttime? This part of the earth is experiencing what? Of course, the answer is nighttime. So you're right. No, I don't see the sun. That is the answer to the question. Do you see the sun? And is this part of the sun, the earth experiencing daytime or nighttime? Then you answer yes. This is part of the earth experiencing nighttime. All right. Then slowly turn counterclockwise. This. You see the picture? Counterclockwise. You turn yourself counterclockwise until this left hand is seen by the torch or the sun. So, right here, at your left shoulder, at this position, is this part of the sun experiencing sunrise or sunset? What is your answer? Yes, this is part of the earth experiencing sunrise. Very good. And now we go to number 10. Number 10. In which direction is the sun? When you see from this position. Remember, you changed your position already. And so, the sun is from the east. All right. And number 11, then turn counterclockwise again until the torch is shining at your right shoulder. At this position, number 12, is this part of the earth experiencing sunrise or sunset? What do you think based on the picture? Yes, this part is experiencing sunset. All right. Number 13, in which direction is the sun when you see from this position? Yeah, the sun is in the direction toward the west. Okay? And number 14, what happens if you do not turn at all? What will happen? Well, will there be any sunrise and sunset? What do you think? Of course, no. There will not be any sunrise nor sunset. Number 15. If you turn clockwise, remember? Counterclockwise, now clockwise, like your clock's direction. Will the directions of the sun rising and setting be in the same as when you turn counterclockwise? What is the answer? Think, imagine, think, and imagine. Yeah. No, it will not be the same. And number 16. What is your conclusion for this activity? I want you to become scientists like Albert Einstein, my brother, who has hair on his side part of his hair, no hair on his head. At the top part, I'm following him. But you can be like him in his wisdom and intelligence right now if you can do it by yourself. yet you can be like him, like he is right now. Or if you cannot, never mind. Here is my answer. I therefore conclude that the sun rises in the east and sets in the west. Why? Because of the counterclockwise rotation of the earth. And what is your evidence for your conclusion? Well, the evidence is the rising of the sun in the east and setting in the west with the earth's counterclockwise rotation. Okay, let's laugh. If you can laugh, what holds the sun up in the sky? What do you think? Is somebody holding up there? The sunbeams? I'm not laughing. I hope you will. All right. For now, bye-bye. And see you next time. Post your answers below.